A field is a variable that is declared directly in a class to store data of any type. Fields in a class are declared by specifying the access modifier, followed by the type, and then the field name. Finally, semicolon. Hello guys, welcome again. The first class member we'll discuss is the field, which is one of the fundamental members of a class. It's similar to a variable, but it's defined at the class level instead of the method level. The key difference between a field and a variable lies in their scope of access. All the variables we've covered so far in our C# courses have been local variables. A local variable is declared within a method and can only be accessed within that method. On the other hand, a class field can be accessed from any method within the class. In a sense, the difference between a variable and a field boils down to their declaration. A variable declared at the class level is referred to as a field, whereas a variable declared within a method is typically just called a variable or local variable. To better understanding, let's explore fields in action using VS Code. First, let's define a class using public keyword, class keyword, class name, in this case a square. Next, we'll declare a field by using the public keyword or access modifier, followed by its type, in this case float, and its name, let's say side. Then, let's define a method that calculates the perimeter of the square. Inside the method, we'll declare a float variable named perimeter. And let's assign it side multiplied by 4. We'll then return the calculated perimeter as a result. The second method we'll define is calcArea, which calculates the area of the square. Inside this method, we'll declare a variable or local variable named area and assign it side multiplied by side. Finally, we'll return the area as a result. It's important to note that the area variable, which is declared in the calcArea method, can only be accessed within the scope of that method. For example, if we try to use the area variable in the calcPerimeter method, we'll encounter an error stating the name area does not exist in the current context. But the side field can be accessed throughout the entire class scope. As you can see, the side field can be used in both of these methods. This is the key difference between fields and variables. Additionally, another difference between fields and variables is the presence of access modifiers. Unlike variables, fields can have access modifiers such as public, private, and more. In the upcoming lectures, we'll discuss access modifiers in detail. However, for now, it's important to understand that these access modifiers define how users of the class can access the fields. In general, it's recommended to assign private and protected accessibility to fields, and the data that these private and protected fields store should be accessed by client code through methods, properties, and indexers. Okay, let's show you why we should do this. For example, let's create an instance object using the square class. Then, let's set the side field to -10. Now, let's print the side, area, and perimeter of this square object. Let's run the application to see the result. As you can see, the perimeter of this square is -40. This happens because we can assign any value to the side field, even invalid numbers like -10. As you can see, using public fields is a bad practice because it bypasses validation, limits flexibility, and can cause unexpected behavior. To avoid such issues, let's expose the side field through a method. In order to do this, first let's change the access modifier of the field to private. Okay, when we changed the access modifier to private, we encountered an error stating a square does not contain a definition for side. Also, according to the naming convention in C#, non-public fields are written in camel case and prefixed with an underscore. So, in this case, the name would be _side. Now, let's define a method named setSide to set the side field outside the class. This method takes a float parameter named side. Inside the method, we first check if the given number is greater than 0. If it is, we assign the side value to the side field. Otherwise, we print an error message indicating that the number is invalid. Okay, now let's use this method to set the value of side outside the class. Here, we still have an error because the side field is private and cannot be accessed directly outside the class. To fix this error, let's access the side field through a method. To achieve this, we can define another method using public followed by its return type, in this case float, and its name getSide. Inside the method, we'll simply return the value of the side. Now let's use this method to retrieve the value of side. Alright, let's run the application again to see the result. As you can see, this time we encounter an error message and the value of side remains unchanged. This is because -10 is an invalid value for the side of a square. Okay, you should know that in C# the default value of numbers is 0. Since the side field does not have an initial value, we need to assign a value to it before using it. Otherwise, it will have the default value of numbers, which is 0. Okay, we have an option to assign an initial value to fields during their declaration. For instance, let's set the default value of the side field to 5. And run the application again. As you can see, this time the value of side is 5. Okay, now let's change the value to 8 in the setSide method and run the application for the last time. As you can see, this time we don't encounter any error messages because 8 is a valid value for the side. And as you may have noticed, it also overrides the default value of the side field. It's important to note that the recommended way of accessing fields from outside the class is through properties, which we'll discuss in upcoming lectures. Alright, in summary, fields are class-level variables that are used to store data and can be accessed from anywhere within the class. They can also be accessed from outside the class, but it is considered best practice to declare them with private and protected access modifiers and use properties for accessing them. We can also initial their value during class declaration and override their value with the desired value. Okay, done. See you soon with another lecture.